Lesson 10.2, Task 3. Solve an exponential equation algebraically. In addition to estimating solutions of exponential equations using a table and solving them graphically, you can also solve exponential equations algebraically. Some exponential equations can be solved directly by rewriting them so that both sides of the equation are exponential expressions with the same base. All right, make a note of that. They have to have the same base. All right, so a property of equality for exponential equations for all real numbers b not equal to 1, x and y, b to the x power equals b to the y power if and only if x equals y. All right, so that's important to know because if and only if means it has to go both ways. In math, that means it has to go both ways. All right, so it says solve the equation 3 times 2 to the x plus 3 power equals 96. So let's look at how we would solve this. So we've got 3 times 2 to the x plus 3 power equals 96. All right, so just like with absolute value, just like with radical equations, you have to isolate your exponent first. So we're going to isolate that by dividing by 3 and getting rid of that first. So we're going to have 2 raised to the x plus 3 power, and then 96 divided by 3 is 32. All right, now, above it said we had to have the same base. 2 cannot be reduced any further. Okay, that's a prime number. So can we write 32 as a power of 2? And that's what we need to decide. Okay, so 32, if you think about a power of 2, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's 1, 2, 3, 4, 5. So 2 to the 5th power is the same thing as 32. So we just rewrote 32 as 2 to the 5th power. Now they have the same base, so we can set the exponents equal and solve. So x plus 3 equals 5 minus 3, x equals 2. All right, and you can see that they've solved and got x equals 2 as well. Now, can I check that? Of course you can check it. So go back to the original equation. And so we have 3 times 2. We solved for x. Now we know that x is 2, so 2 plus 3. And does that equal 96? All right, so that's 3. Properties of exponents, I'm going to do 2 plus 3 and get 5. And you always have to do exponents before you multiply. Order of operations, 2 to the 5th again is 32. And 32 times 3 is 96. So 96 equals 96. So you can see that that does check out. Okay? All right, so let's see what the question asks in this problem. What reasons justify the last 2 steps of the solution? All right, so we've gone from here to here. So in order to rewrite this, that's going to be your property of equality for exponential equations. We just went from 32 to 2 to the 5th. We just rewrote that as an exponent. And we're working with equations. So that's just called property of equality for exponential equations. And then we subtracted 3 from both sides to get 2. That is just your subtraction property. All right, so moving on, y is the first step of the solution. Divide by 3. Again, same thing with absolute value and radical equations. This is an exponential equation, so you have to isolate the exponent or the exponential part first before you can solve. Okay? So if you have any questions, please let me know. Lesson 10.2, Task 4. Solve an exponential equation algebraically. For many exponential equations, it will not be possible to rewrite the 2 sides of the equation using the same base. So if you remember task 3, we had to have the same base in order to solve. But a lot of equations, you're not going to be able to do that. To complete the solution, when this is the case, you can rewrite the exponential equation using the definition of a logarithm and then solve the resulting equation using the properties of logarithms. All right, so we're going to look at another example, but this time we're going to solve using logarithms. All right, so let's look at this equation. We've got 5 times 3 to the x power minus 7 equals 43. All right, so it's an exponential equation, which means in order to solve, we have to isolate the exponential part. So that means get rid of everything else first. So I'm going to add 7 to both sides. So I'm going to have 5 times 3 to the x power, and that's going to equal 50. I'm going to divide both sides by 5. So I'm going to have 3 to the x equals 10. 5 goes into 50 10 times. All right, now, this is a prime number. This is my smallest base. Can I rewrite 10 as 3 to some power? No, 3 to the first is 3, 3 squared is 9, 3 to the third is 27. So I cannot rewrite this. So then we have to resort back to logarithms, which we learned a couple days ago. So remember, this is your base. So you're going to have log base 3 of 10 equals x. So we're going to have log base 3 of 10 equals x. And this is what we worked with the other day, just properties going from exponential form to logarithmic form. All right, now there's two things you can do. You can go to your calculator and use your handy little button I showed you before, where you can go to, all right, if we go to math and we go over to, or go up to A, and it's going to say log base, we can enter any base here we want. So we can do log base 3 of 10. So log base 3 of 10. And then that will solve it for us. So x is going to be about 2.1. Okay, so it rounded to the thousandths place. So let's round to the thousandths. So 2.096. 2.096. All right. All right, so that's using, again, the math and the log base button. You can also use the change of base formula, which we learned. So it's going to be log of 10 divided by log of 3. So we can just do log of 10, and we can divide that by log of 3. And this is handy to know in case you have a calculator that doesn't have that log base button on it. This is a way that you can get the same answer very quickly without that. You may have a phone that has a logarithm button, but it doesn't have the log base button. And if you just have the LOG button, remember that assumes it to be base 10. So using the change of base formula is a way to get your answer without a TI-84. All right, so why can't the property of equality for exponential equations be used at the point where the equation is 3x equals 10? Okay, so again, 10 cannot be rewritten as a base of 3. So since 10 is not a power of 3, the two sides cannot be written with the same base. All right, what property justifies this step? Okay, that's your change of base formula. And I could simplify the numerator. Okay, so the numerator is just log of 10. So that reduces to 1 since log of 10 equals 1. Okay, that's one of the properties we learned in one of the previous lessons. All right, that's all for task 4. If you have any questions, let me know. 10.2, task 5. Real-world problems modeled by exponential equations. You can use algebra to solve real-world problems that are modeled by exponential equations. For example, the amount of medicine that remains in a body decreases exponentially over time as the body processes the medicine. So the amount of medication remaining in a person or animal's bloodstream at any given time since the medication was administered is modeled by an exponential decay function. All right, so you can see the function here, A equals 300 times 1/2 raised to the t over 15 power. During an annual checkup, a veterinarian diagnoses arthritis in the hips of Marissa's dog. The veterinarian instructs Marissa to give her dog one 300 milligram tablet of a medicine per day to treat the arthritis, and then administers the first tablet. The amount of medicine A remaining in the dog's bloodstream after T minutes can be expressed by exponential decay. How long will it take for the amount of medicine to drop to 75 milligrams? All right, so A equals the amount. So we want to know when it's going to be 75. So you're going to divide both sides by 300. Okay, let's go ahead and work this out. If I can get my pen to work here. All right, so don't know why my pen doesn't want to work half the time. All right, so A equals 300 times 1/2 to the t over 15. All right, so we want to know when it's going to be 75. So you're going to isolate your exponent. So we're going to get rid of the 300, 75 over 300. 75 and 75 is 150, so that's 2, so 4. So 1/4 equals 1/2 to the t over 15 power. All right, from here, we can say, can we rewrite these as the same base? Okay, so you can either write this as 2 to the negative 1 power, or you can leave it as 1/2 and say if I take 1/2 and square it, I get 1/4. So let's rewrite 1/4 as 1/2 squared, because you would square the numerator, which is 1, square the denominator, which is 4. So all we did was rewrite 1/4 as this. All right, if I get the same base, then I can cancel my bases because they're equal, and I can set my exponents equal. So 2 equals t over 15. If I'm dividing by 15 to get t by itself, I have to multiply by 15. 2 times 15 is 30. So t equals 30. All right. Now let's see what it says. What has been done in step 4 of the solution? What alternative way could have been done? All right, so you could also have wrote this as a negative exponent here. So it says the left side of the equation was rewritten as a power of 1/2, matching the base of the exponential expression on the right. Both sides of the equation could have been rewritten as an power of 2. So 2 to the negative 2 equals 2 to the negative 1 over 15. And that would give you the same result. All right, so what is the justification for step 5? 2 equals t over 15. So that was your property of equality for exponents. And it says, so it will take 30 minutes for the amount of medicine to drop to 75 milligrams. The result can be verified by graphing the two sides. So they've graphed 75 here, and they've graphed the exponential decay function here. And you can see at 30, 75 is when they intersect. So how does the point of intersection confirm? The point of intersection is 30, 75. So the t coordinate, or the time coordinate, this time it's t instead of x, is your solution. All right. If you have any questions, please let me know.